Hi guys, in this video we will be discussing some miscellaneous examples for the topics covered till now. So let's start with our first example. So the problem is to find derivative of y with respect to x, where y is given by 9x squared plus 5x, and this we need to achieve by using the first principle. So let's start with our solution. So as you guys could recall, by the first principle, derivative, that is f prime x, which we can also write as dy by dx, as we need to find the derivative of y with respect to x, which can be written as f of x plus h minus f of x over h, and this is whole under limit h approaches to 0. Now it is f of x plus h. Let's say this y is f of x only, so f of x plus h will be 9 times x plus h whole square plus 5 times x plus h, and this fx will be 9x square plus 5x, and this thing as a whole is divided by h. Now let's see if we can simplify this. So it opens as 9x square plus h square plus 2xh, and this 9x square both have 9s common, and the remaining thing is 5 of 5 times x plus h minus x. So this thing is divided by h. So x square gets cancelled with this x square, and this x gets cancelled with this x. Right. So what remains after this is limit h approaches to 0. And now we see that in the numerator, all the remaining terms have h in common. And since h is not equal to 0, so we can cancel out one h from both the numerator and denominator. So the remaining things are 9 times h plus 2x plus 5, as the h got cancelled from both the numerator and the denominator. So now we can simply put h approaches to 0 here and evaluate the limit. So when h approaches to 0, this whole part becomes 9 times 2x, that is 18x plus 5. So the answer is 18x plus 5. Also, you can verify the result by using some of the properties which we have been discussing throughout the course. So you will calculate like 9 times derivative of x square, which is 2x. So this thing becomes 18x plus 5, as derivative of x is 1. So we have even verified the correctness of our answer. Okay. So now let's take another example in which we need to find dy by dx for y, where y is equal to sin x minus cos x. Okay. So now let's see how to calculate the derivative in this example. So if we suppose this function as f of x and this function as g of x, then dy by dx can be written as d by dx of f of x minus g of x. Now you must have guessed which rule of algebra to apply here. Yes, we need to apply the subtraction rule here. So by subtraction rule, we can write this thing as d by dx of f of x minus d by dx of g of x. So this is the subtraction rule which we have applied. So this we have already covered in a previous video, as you guys must be knowing that. So now d by dx of f of x, that is d by dx of sin x, minus d by dx of g of x, that is d by dx of cosine x. And now I have mention all the basic rules for derivatives of common trigonometric functions. So d by dx of sine x from there is cos x, and d by dx of cos x is minus sine x. So this is minus minus sine x, and two negatives obviously combine to form a positive. So this will be cosine x plus sine x. So the answer is cos x plus sine x. So the derivative of this function, or dy by dx for this function, is cos x plus sine x. So that was our second example, and it was based on the subtraction rule from the algebra of derivatives. So now let's take a look at another example where we need to find dy by dx when y is equal to 2 by x plus 1 minus x square over 3 by 3x minus 1. So this is our function y, and we need to calculate dy by dx here. So now as we can see, let's assume this function as f of x, this function as f of x, and this function as g of x. So now as we saw in the previous example, that dy by dx can be written as d by dx of y. The y is f of x minus g of x. Okay. So as we have already assumed f of x and g of x, so from the subtraction rule of algebra of derivatives, we can write this as d by dx of f of x minus d by dx of g of x. And d by dx is of f of x is differentiation of this function, and d by dx of g of x is differentiation of this function. Now in both of these functions, f of x and g of x, we can further apply division rule of the algebra of derivatives. Okay, as both of these functions are individually a division of two functions. So to calculate the derivative of these two functions, we require the quotient rule. Alright, so firstly we will calculate the d by dx of f of x using the quotient rule, and after that we will calculate d by dx of g of x. So now let's first calculate d by dx of f of x. So d by dx of f of x, the derivative by quotient rule, is denominator function, that is x plus 1, multiplied by derivative of numerator function, which is 2, and the derivative comes as 0, minus numerator times derivative of the denominator, which is 1, and this whole is divided by denominator whole square. So first part is 0 and the second part is minus 2. So this will become minus 2 over x plus 1 whole square. So the differentiation of f of x is minus 2 over x plus 1 whole square. Similarly, we will evaluate derivative of g of x with respect to x. So d by dx of g of x, as per the quotient rule, our numerator and denominator here are x square and 3x minus 1 respectively. So we'll write it as denominator multiplied by differentiation of numerator, that is derivative of x square, which is 2x, minus numerator multiplied by derivative of denominator, so derivative of 3x minus 1, that is 3 minus 0, and this whole is divided by 3x minus 1 whole square. So let's now simplify it as this will be 6x square minus 2x minus 3x square, and this whole is divided by 3x minus 1 whole square. So this is 3x square minus 2x over 3x minus 1 whole square. So now we have successfully calculated derivatives for f of x and g of x respectively. So now we just need to merge the results to get the final answer. So dy by dx is is d by dx of f of x, that is minus 2 over x plus 1 whole square. So the first part is minus 2 over x plus 1 whole square minus d by dx of g of x, which we have already calculated as 3x square minus 2x over 3x minus 1 whole square. So this is our final result. So the dy by dx, or you can say the derivative of y with respect to x, is coming like this. So we used two rules of algebra, that is subtraction and division rule, to evaluate the derivative for this function. Okay. So this was our third example. Now let's take one more example in which we need to calculate dy by dx, where y is equal to under root sine x, right? So how do we calculate this derivative? As we see that this y is a composite function, where we can suppose this as the inner function and name it g of x, and the outer function as root of x. So we name it as f of x. So this is the composite function, this whole. So I'll try to explain it in another manner. Let's say we have an input variable as x and the function is sine. So when we pass x from this function, the output comes as sine x. So, and when this output, this sine x, is passed through another function which applies the root to the input, we get under root sine x as the output. So this is our composite function. This is x, this represents g of x, this function, and the output of this is g of x, and this is f of g of x. So this one is the outer function and this one is the inner function. Outer function is f of x and inner function is g of x. So let's write it here. G of x, so g of x is equal to sine x, and f of x is equal to under root sine x, and hence f of g of x is equal to under root sine x. So dy by dx will be d by dgx, that is the inner function according to chain rule of the, we differentiate the whole composite function with respect to the inner function multiplied by the differentiation of the inner function with respect to the input variable on which this inner function is defined, that is x. So now this f of g of x is under root sine x and g of x is sine x. We need to calculate d by d sine x of under root sine x multiplied by d by dx of sine x, that is cos x. So let's see how we can calculate d by d sine x of under root sine x. So let's assume we need to calculate d by dx of under root x, so which we can write as d by dx of x to the power half. This will be 1 by 2 multiplied by x to the power half minus 1, that is minus half. So which results in 1 by 2 root x. So derivative of root x with respect to x is coming as 1 by 2 root x. Similarly, we can say that dy, and let's say another variable, d by dy of under root y will come as 1 by 2 root y. So similarly, d by d sine x of under root sine x will be 1 by root sine x, 1 by 2 root sine x. So our end result will be d by dx d sine x of under root sine x times cos x. So this thing is 1 by 2 root sine x. So our answer will become that is 1 by 2 root sine x times cos x. And here we use the chain rule to evaluate our result. Okay. So now let's take another example on chain rule only, as it is a bit tricky. And this would be our last example. So in this example here, we need to calculate the derivative of y with respect to x only, where y here is e raised to the power x square plus 5x plus 3. So this is our function in question, and we need to calculate dy by dx, right? Now as you can see here as well, that function y, that this function y is a composite function. Okay, where this is the inner function g of x and this is the outer function f of x. So this is the outer function. So let's writing it separately as g of x is equal to x square plus 5x plus 3, and the outer function is f of x is equal to e to the power x. And if we plug in g of x in this place of x in f of x, we find f of g of x is e raised to the power x square plus 5x plus 3. So now let's apply the chain rule to calculate the derivative. Okay, since we validated f of x and g of x. So now again from the chain rule lecture, we know dy by dx will be derivative of the composite function with respect to the inner function multiplied by the derivative of the inner function with respect to the input variable, which is x. So now let's substitute the values. So gx is x square plus 5x plus 3. So and f of g of x is e raised to the power x square plus 5x plus 3 multiplied by d by dx of gx, which is x square plus 5x plus 3. So the second part, this part is very simple, right? And the first part, this part is a little trickier. So now let's suppose this thing is some other variable y. So d by dy of e raised to the power y, which we know is e raised to the power y, or we can take some other variable, let's say it is t. So d by dt of e to the power t will again be e to the power t. So similarly, d by dx square plus 5x plus 3 of e raised to the power x square plus 5x plus 3 will be e raised to the power x square plus 5x plus 3. Okay guys, multiplied by the derivative of this second term, which is 2x, as differentiation of x square is 2x, plus 5 as differentiation of 5x is 5, and plus 0 since differentiation of a constant is 0. So the answer is e raised to the power x square plus 5x plus 3 multiplied by 2x plus 5. So this is the answer. So these were some examples based on derivatives. I hope you guys must have understood the concepts and enjoyed watching the videos. Thank you guys.